Hello, everybody. So it's a little strange to be an infrastructure engineer at a mobile conference. Like many of you, I was wondering, why am I here? Right? So unlike the previous speaker who had really exciting, excellent demos to show for everything he said about, I only have stories. And the kind of stories that software engineers are probably not, dreaming of. My kind of story is to give you a little bit of background, I'm the tech lead on the cache team. So the kind of thing I work on are, adapting memcache to Twitter's need and, modifying Redis. I actually gave a Redis talk a little bit ago, and actually rewriting a lot of infrastructure to make sure all the data flows quickly and smoothly. So that's the kind of thing I do. And the story that I experienced in my almost 4 years at Twitter, is at the beginning, when I restart a cache, back during the days when timelines were using cache, what happened is you would see about 10 fail whales out of every 100 requests. That's me doing my job by maintaining an instant of cache. So as you can see, that was the time when I had to stay past probably 9 p.m. Better yet if you do it at midnight, so you have a 5% dip in success rate instead of a 10% dip, which happens during peak time. So we've come a long way from the old days when fail whale kind of is another name for Twitter, and it has a cult following, but that's no more. So today I'm going to tell you a little bit of the story about how Twitter grew up as an infrastructure, and what I think might be relevant for everybody who's writing software, not just infrastructure engineers. So that's so much about me. First, my understanding about scalability, about scaling infrastructure, I think it's a story about growing up. It's in many ways, it's a very sweet problem to have. When you have a scalability problem, you're growing. And for a lot of people writing services and applications, having growth is a wonderful thing. And it is also true that most of the time we need to balance between solving the scalability problem, providing a reliable service, and grow. And usually grow needs to happen first. If you don't have a solid base of users and of audience, it's kind of a moot point, right, to solve the scalability issue beforehand. But eventually, if you are successful, which I'm sure many of you are or will be, you will have to grow up, like from a very fancy, nice prototype into something that people have to depend on, they cannot live without. And that's when the service and the app has to show integrity. And by integrity, I mean it has to be available all the time. Nobody can imagine at this point Google going down even for just a minute, right? So you have to be available. And same thing goes for Twitter. If Twitter goes down, it's going to be a disaster for me, at least. The second thing is responsiveness, right? And you expect the service to be there. You also expect you get what you want quickly and in a deterministic amount of time. And the last thing is quality. You want the result to be correct, and you want it to be consistent. So once you solve the growing problem, then you have to become a matured service so people can keep relying on it. So that's the story of scalability. It's essentially growing up. And Twitter went through exactly that in the past, since the beginning, but especially so in the past 3-4 years. So I'm going to tell you a little bit about what Twitter went through. I think the most noticeable change is in its core infrastructure. Let's look at what Twitter was before, right? So this is the Twitter in 2009, and this is the Twitter So we have much more than that, but today's Twitter pretty much look like that. The difference is, previously we have this monorail, which is like a black box where all the logic goes into that talk to various databases. The problem with that is if you have 15 people who want to do something about user, you have a path that registers user, you have another path that updates a user or creates connections between users. There is a lot of activities happening from this gigantic opaque box going to the backends. And the problem with that is, now if you want to do something to the back end, now you have to go and change 15 people's code, right? And that's really hard. So what we decided is that we're going to take a good look at this opaque box. We're going to give it structure, first by figuring out what we are trying to do and divide those functionalities into tiers. Then we break up those functionalities into even smaller blocks, like TweetyPie would be the service that's in charge of all the tweets. So every tweet you will see flows through TweetyPie. And GizmoDuck is the service that deals with users. So if you're a user, then all the user data will flow through this service. When it comes to scalability, the advantage of this approach is if we need more capacity in user services because a lot of users sign up, we know where we should beef up our infrastructure. Unlike here, we may be touching 50 different places, and it's very hard to scale just one point because that's where the growth is coming from. So this is the big architecture change. We matured from a monorail that's running on Ruby, which is not the most efficient runtime out there, to a service-oriented architecture with much more efficient runtime like the JVM. But like the Chinese says, what's united will eventually be separated, and what's separated will be united. While we are separating out all those services into their own modules, it's not like we are running now 50 different companies and each one of them is holding on to a small piece of Twitter, right? That's not the case. So underneath all this separation in their identity, there's actually a lot of unification happening as well. And I think they happen at two levels. The first level is the platform. So all the services that we saw on the previous slide actually run on a very small number of platforms. Mesos Aurora is our container job scheduling platform. So if you're running a service which needs 100 instances, you just create a job and tell Mesos Aurora to schedule those 100 instances with your binary for you. And then you have a cluster of 100. If you want to scale in a week because you have a tremendous growth, you can say, I now need 200 instances. And it's as simple as changing one number in the job description, and the platform would do the rest for you. The same story is repeated on other platforms. Manhattan is our flexible, structured key storage platform. So all those teams who are running their own services and managing their own data actually request capacity from this one single platform, and their request can usually be fulfilled, instantly through self-service or very quickly if they have to be, added capacity. And same goes with Storm, which is our stream computing platform. So this gives you pretty much near-time capability of analyzing your data, and actually we use this even in a lot of our backend projects to gain like real-time insight into our data. So we know when there's a hotspot, we know when things are falling apart, or we know some worthwhile news is coming through. So different applications, same platform. And if you go and look at the libraries, there's even more reusable components in there, right? So Finagle is our RPC framework. We have also load testing framework like Yago, and we have Ostrich, which is our observability library. We have Scolding and Zipking. All these libraries are everywhere. If you go find different teams and see who's using any of these, you can find dozens, if not over 100. Teams using the same component. So what this means is even though we are running our entire infrastructure in separate services so we can scale them individually, we are reusing a lot of our technology in the forms of libraries and in the forms of platforms, so people can focus on working on a small number of core libraries and platforms to improve the quality and improve scalability. So basically, what I want to tell the Twitter story is, yes, we separate out the monorail into individual services, but we also put a lot of effort into unifying what is common, the commonality between all these different services, and capture that in our platforms and libraries so we can provide better service and better scalability overall. So here is to my take on the question, why is an infrastructure engineer talking at a mobile conference? For anybody who does not work at Twitter, or more specifically for anybody who didn't work at Twitter when this happened, it's actually not, the exact details is not relevant. But if you look at all the scalability problem, regardless of you're writing a mobile app or a website or any other applications, a bank application, there are a few principles that I believe is universal, and there are lessons that we learned only through failure and through sometimes disasters that we realize they're important. And I want you to know this beforehand, so you don't have to make the same mistake that I stayed up until 3 a.m. to fix, right? So the first principle, I think, this is not just for scalability, but for writing good software in general, is that abstraction really is the soul of scalability. What do I mean by that? So imagine we had the monorail, but we did it in a disciplined way. We say everything that's related to a user needs to go in a class or in a module, and everybody who wants to access user needs to use a method of that module or refer to that class. So imagine if you have that, what happens when you say, I want user to be running in its own service because I need to scale it better, but I don't need to scale the rest of the components at the same rate, so I only want to separate out the user module. It will be easy, right? Anybody who's referring to user is already referring to this class. So if you move it out, turn it into an RPC, turn it into a different endpoint, people can make requests. They just need to make a slightly different request, and everything else you can take under control. You don't have to worry about breaking anybody's code once the interface change is done. So that tells you why abstraction is important. If you don't have such abstraction, now if you make any change to anything, you will break someone's code. And it will be 5 times or 10 times harder for you to separate those out. And we actually are paying for this still. Even though most of Twitter's infrastructure has moved away from monorail, there's just some parts in monorail that's kind of convoluted and doesn't have enough traffic for people to invest time into, that we still run monorail somewhere, in that little corner nobody wants to talk about it, everybody wants to move away from it, but 5 years and we are still moving, right? So this tells you why abstraction is important. If those are properly encapsulated and they just need to be shipped off from Ruby on Rails, the environment, and to some individual services, that won't be so hard. What's hard is we screw up on the abstraction, and therefore we have to pay for it. So if you do the abstraction right beforehand, you don't have to write microservices, right? People are like, my application is not big enough. I don't need 5 different services to serve this one application. Fine, you can put them in 5 modules, put them in 5 files. It will be great when you have to move it. So another example is how it evolves. So on the cache team, we adopted memcached and Redis as is, right? So these are completely 2 open source projects. They're completely different things as when they came to us. But the more we look at it, the more similarities we saw. So if you look at cache, it's a way of for applications, to get some data that's not necessarily on the same machine, but most likely not on the same process over the network very quickly. That's all cache does. Whether it speaks the memcached protocol or the Redis protocol, whether it supports data structure or just simple key value store, one thing doesn't change. You need to have a very efficient network I/O. So if we look at these applications who are already separate identities as what they really are, we realize we need a single abstraction to capture the commonality, and that's exactly what we're doing. So this is a project in progress, but we are rebuilding the abstraction. We say a cache is memory management sitting on top of very efficient network I/O, and on top of that, we can build in other things like data structure, but we will make it so. So all these different cache components can become offering one common interface. And that, I think, is going to improve the quality of our service and make it more usable for the user. So abstraction is not something that's fixed. I think it's a myth that you can write your infrastructure once and just use it forever, right? If that happens, it's probably the best trade to get in your 20s, right? So systems evolve. So you need to look at something, so as you build new features, as you scale, as the workload shifts, something will start to feel a little weird. They don't match. So this is when you should take a very serious look at the architecture. It's the assumptions, do the boundaries I drew 2 months ago or a year ago still fit the problem I'm trying to solve right now? If that's not the case, refactor. Because if you refactor now, it will take you a week. If you refactor 2 years down the road, it will take 10 engineers 3 years. So that's the difference. The next thing I want to talk about is visibility. Visibility is crucial, cannot be overemphasized. Think about a modern hospital that doesn't have MRI or microscope or any of those things that allow doctors to see pretty much anything on your under your skin. Right? Basically the modern medicine cannot function without visibility into the system. Same goes here. But if you are coming from school or any project that starts from a very nice prototype, visibility is usually an afterthought. You'll be like, I'm going to throw in 3 metrics in here so I'm not completely clueless about how the system works. But same goes with the abstraction. If you have to choose between building in some feature that you think is going to be nice down the road, or if you think I'm going to improve the performance of this module, or you can choose to improve the visibility into the system, always go for visibility. So when it comes to visibility, I'm resorting to tools like tracing, logging, and metrics. So these are the common ones. I'll give you an example of how this helped us prioritize. Right? There was one case when we have our big user, TweetyPie, coming to us. They're the biggest cache user. We really care about making them happy. So they came to us, they're like, our cache is slow. You need to make your cache faster. I'm like, okay, our cache is slow, but why is it slow? It usually runs fairly fast in my benchmarks. I don't understand. So what we did is instead of say, let me just remove those memory operations from the backend, hoping that it will be a little faster. What we did is we take millions and millions of packets between the cache server and our service through TCP dump, feed it into Wireshark, which is a tool that tells you everything about the packets that flows through network. And we say, let's measure it. Let's measure how long it takes for a packet to leave the TweetyPie box and arrive on the cache box. And again, how long it takes for it to return from the cache box back to the TweetyPie box, and what's the round trip time for the trip. And we did that. So while the client was observing something like 5 millisecond latency or 10 millisecond latency in their P99, what we found is the P59 latency, when you measure it inside the kernel, is 200 microseconds. So that's more than an order of magnitude difference. What does this mean? It means that any improvement we are going to do or we ever did in the server won't matter unless we solve the problem of the application issuing a request and receiving the response, and too much time is spent between the client's kernel and the client's application. So that's where time should go. We should improve the client library. We should improve, maybe the JVM runtime. But before then, we shouldn't do premature optimization on the server side. Like, you all know the saying that premature optimization is the root of all evil, which is definitely true. I believe everybody here has the capability of solving a scalability issue if you know where it is. But the important thing is to find out where the problem is, and don't make assumptions on that. And visibility gives you exactly that. The third thing is system knowledge. Systems knowledge is useless when everything works flawlessly. That's the whole point of abstraction, is to hide away the details that you shouldn't and don't normally care about. Right? If you are running in the cloud is just this endless resource of CPUs and memory. You can request however many you want. It scales seamlessly. Excellent when it's in the normal condition. But when things break down, suddenly the clean interface is not so clean anymore. And often people who don't look done will get confused. And we have just an example for that as well. Like none of this I'm making up, none of this is something I learned after spending 3 weeks fixing something and realized I was looking at the wrong place. And this is one of them. So we had an issue a few years ago when users were complaining about sometimes their passwords get reset, like they have a new password, but their old passwords was actually getting used for them to log in, and they're like, this is a security, this is a big security problem. You gotta fix this. So we looked everywhere. We looked at the logic that updates the password, we looked at the database, everything was okay. And then we suddenly realized we were all looking at the application logic, but never looked at the system below. So we started poking. And what we found was the network at the time had a there was a driver issue. So that particular version of the firmware for the NIC has this periodical packet drop behavior. So every once in a while it throws a few packets on the floor, but if you look at the chart over a period of time, it's actually not that bad. It's like 0.01. Nobody's going to be alarmed if that's happening. But they happen in a very spiky fashion. And this spiky fashion has its consequences that coincides with how we handle failures and propagates all the way up until it affects user data consistency. So this became one of my favorite interview questions because at the time it felt really intriguing. How could this happen? And I tossed this question to SREs, reliability engineers. And they're like, oh yeah, first thing to look, network. I'm like, it took us 5 days to land on this clue, but you got it in 5 minutes. Then I realized that's what they do, right? These are the people who look at systems up and down. They know all the common problem patterns. They know all the diagnostic hints. So if you are writing a system and you want to prepare yourself for the downtime, when things go wrong, look down. If you don't have the time or energy, hire someone who knows how to look. It will pay off. So finally, as a last resort, you can toss out everything I just said, those 3 points. Like, I don't have time for abstraction, I don't want visibility, I fly blind, and everything. This you have to have, which is what I call owning the master switch. I don't think anybody here would build an application from ground up. Most likely, you will use some existing technologies, right? You will use, if you're using caching, use Redis or Memcache. If you're using database, there's like at least 20 of them to choose from. So you will build your service on something that's already existing, and you surely hope you made the right choice. But the truth is, I write services, so I know. Like I claim to write good services, but even this is true for the services I write, is that most of these services have a cliff. Most of these services don't fail gracefully. What I mean by that is, think about a Java process. If you run into a GC spiral, can you dig yourself out of it without restarting? Most likely not. So all of these services have similar problems. If you go over the cliff, go over the capacity, MySQL has this problem with the connections. If you run over the connection limit, it actually won't do anything. It's just keep pinning on that. So most of these services, once they go over their capacity, they drop everything or most things on the floor. And what do you do at that point? You restart your services. Now you have a warm-up problem, right? Your service maybe need to set up, but traffic is already coming in. So before the service can go into a steady state and serve traffic again, everything gets dropped on the floor, and you can never climb up. So what do you do when basically everything fails? Right? We had this problem when we lost like 40% of our racks in one data center. Some services, a lot of services simply cannot recover from that kind of disastrous failure. So what we need in this kind of situation, when you're not ready to take on the scale that is coming, what you need is a way of controlling how much traffic you let through as early as possible. If you can do it at the reverse proxy, do it at the reverse proxy, but as early as possible, and control what kind of traffic gets through and what kind of traffic goes where. So we have this system that we call decider, which is exactly that. So basically, if you incorporate decider in your logic, you can say, I want 1 out of 10,000 packets to go through, requests to go through, or you can dial it all the way up into 100%. So the way we recover from a disaster like losing half of your data center is to trickle some traffic through using this decider system and slowly dial up the traffic as more and more racks recover and system go into a stable state. So if you don't have anything else, building your master switch. If you're using a service, build a switch on top of that saying, I'm going to control how much traffic will be directed to this service. And that will make you sleep much better at night. I know I will. So to summarize, I think these are the things that I learned from working at Twitter and scaling Twitter infrastructure. And I think it should help for anybody to prepare themselves for future scalable issues without investing too much time in them right now. First is to always rethink your abstraction and make sure it's up to date. Second is to track and measure everything you do. It will point you to the right direction and maximize the effect from your effort. Third is to have a little bit of understanding of the platform, not enough to fix everything, but to know where to look and whom to ask and what is the right question to ask.